Moving on to significant figures and calculations. Determining the number of significant figures, or also known as significant digits, in a measurement. Now notice, we are going to be doing these in a measurement, and I'll try to distinguish between measurements and the other thing here in a moment, but we'll start with determining the number of significant figures. Sometimes we'll say sig figs. Right, when I'm grading work from you guys and you see like, minus half a point for sig figs, that's what I'm referring to as an inappropriate number of significant figures relayed in your answer. Some people also, because they're called significant digits, sometimes they'll also say sig digs. I remember my master teacher, when I was working on my credential, used the term sig digs, and that kind of blew me away. But it's actually kind of simple. Anywho. Now, we have to figure out what numbers are significant. Any non-zero digit, non-zero, so that's 1 through 9, anything that's not a 0, is easy. It is significant, okay? Those are the easiest ones. It's all downhill from there. So, between these numbers here, the only other number that I haven't talked about yet is a 0. Okay, those are the annoying ones. Because with a 0, you have to figure out what circumstances and what situations it's in. A 0 is significant if and only if it meets one of the conditions below. And it only has to meet one. So how many different conditions here? 1, 2. So the 0 is significant if the 0 in question is terminating, which means at the end. Right, at the end, to the right of the number, there are no more non-zero digits after it, and to the right of the decimal. Right, so it has to be to the right of the decimal and at the end of the number, and it must be both. Must be both. That is your circumstance. The second way that a 0 can be significant is if the 0 is sandwiched, right? Being sandwiched is pretty self-explanatory. I think most people have pretty good amount of experience with sandwiches, right? If it's sandwiched between two figures that you know are, in fact, significant. So, I referred to earlier as these being significant figures in measurements. And I mean measurements as opposed to exact numbers or counting numbers. An exact number refers to those types of numbers that when I say a word, they conjure up a specific number. Like if I say I have a couple of friends coming over, that's 2 friends, right? That's 2 friends. If I have a couple of quarters, that's 2 quarters. If I have a couple of sodas, that's 2 sodas, right? So this means 2 and exactly 2. Some people, I think the correct version of the word few refers to 3. You guys also know dozen, right? A dozen means 12. If you've ever heard the term a baker's dozen, that's 13. And the story goes that a baker's dozen is 13 because when bakeries and different type of pastry or bread makers became a normal everyday part of life, being able to read and write as well as count was not necessarily everyone can do it type of thing. And so in order to make sure that they weren't, underserving their customers because the counting skills weren't very strong, they'd always prefer to miss high. They'd always rather give you one more donut or bread or whatever you were buying. They'd always rather give you one more as opposed to one too few, because then you'd be a bad baker, you'd be mean, and people wouldn't come back to you. So that way we have this term of baker's dozen. In chemistry, we have the term a mole. A mole actually refers to an exact number, even though we don't use all those digits in that number. It still is an exact number. It refers to a very specific number. Or counting numbers. Right? When I tell you that I have 5 golden rings, when we're getting into Christmas time and we start singing that song, those are counting numbers. I have 1 ring, I have 2 rings, I have 3 rings, 4 rings, and then 5 golden rings. Right? I don't have 5.5 golden rings such that I would need to start considering significant figures. I have 5. I have 5 gold rings. So if I have an exact number or a counting number, I consider every single digit that is related in that figure to be significant, right? They're considered to have an infinite number of significant figures. So you can think of it as if I say I have a couple of quarters, I have 2.00000000000 off to infinity significant figures there. That's how many significant figures I have. And so do fundamental constants, right? A fundamental constant would be something like the acceleration due to gravity, 9.81 meters per second squared. That's considered to have an infinite number of significant figures.